In this chem activity, we will be looking at the aldol condensation. The aldol condensation is the reaction shown on the screen, in which two aldehyde molecules condense together or combine together to make one larger molecule. As you see on the left, we have 2 carbon atoms, and on the right, we have 4 carbon atoms. 2 of these carbon atoms comes from each of the 2 aldehyde molecules used in the reaction. So in fact, you combine 2 aldehydes together. Now the product of an aldol reaction can be qualified by the relationship of the other carbon atoms to the original carbonyl carbon. If this is the carbonyl, we call the position next to it the alpha position, and the position next to that the beta position, just like we did when we did alpha-beta unsaturated carbonyls. And the new bond that is formed during an aldol condensation is the bond between alpha and beta. So if you were thinking backwards about an aldol condensation, you would start with an aldol product, which is always a beta hydroxy carbonyl compound, and the beta hydroxycarbonyl compound has formed a new bond between the alpha and beta position. So how does this reaction occur? Well, if you remember from the beginning of chapter 17, hydrogens that are in the alpha position are more acidic than other hydrogens on a carbonyl molecule. So if you put a base in solution, that base will reach out, grab an alpha hydrogen, and form an enolate ion. The enolate ion has 2 resonance contributors, with the majority of the negative charge located on the oxygen atom. However, the more nucleophilic position is on the alpha carbon atom. We saw this in the previous section. Now, this nucleophile can do bromination and nucleophilic substitution like we've seen previously, but this alpha position can also act as a nucleophile towards another carbonyl. So, for example, if it were to attack another molecule of itself, which is exactly what happens in the aldol condensation, we would end up forming a new carbon-carbon bond, as shown, where the nucleophile ends up being the carbonyl portion of our soon-to-be aldol product, and the electrophile ends up being the alcohol portion. In other words, the nucleophile used its alpha carbon atom to attack the carbonyl of the second molecule, which becomes the beta position, like so. Of course, this process isn't complete until we protonate, which we do in the last step, in the process using up the water that we created in the first acid-base reaction and creating another hydroxide.